capacitor of capacitance 2 microfarad is initially charged to a potential difference of 12 volt. So first of all we can calculate the initial charge that will be present on 2 microfarad capacitor. Let name it as A, and this is my second capacitor B. So the charge on A initially will be Q is equals to CV, that is 2 into 10 to the power minus 6 into 12 volt. So initial charge on capacitor QA is 24 into 10 to the power minus 6 coulombs. Now it is then connected to an uncharged capacitor of capacitance 4 microfarad, CV given to me as 4 microfarad as shown in figure. Now we have to calculate the charge on each of the two capacitors after the connection. Now for that we will use the first concept, that is the conservation of charge. Now obviously that it initially 24 into 10 to the power minus 6 coulomb of charge is available on A, and it will be evenly distributed on A and B. So charge on A plus charge on B will be equal to 24 into 10 to the power minus 6 coulomb. That is nothing but conservation of charge. And secondly, that let's say we have this point and this point. Now let it name it as point 1 and point 2. Now the potential difference across 1 and 2 will be same for 2 microfarad and 4 microfarad. So with respect to point 1 and 2, I can say that the potential difference across 2 microfarad will be equal to potential difference across 4 microfarad. So potential difference across A microfarad is equal to potential difference across B microfarad. So Q is equal to CV, V is equal to Q by C. Using the formula I can write VA as QA by capacitance of A plus QB by CB. On substituting I get QA divided by 2 is equal to QB by 4. That gives me a relation QB as 2 times of QA. Now substituting this equation in this, I get QA plus QB, that is 2 times of QA is equal to 24 into 10 to the power minus 6 coulombs. CQA is equal to 24 microcoulomb. So QA comes out to be 8 microcoulomb, and so QB, that is 2 times of QA, comes out to be 16 microcoulomb. Now second we have to calculate the electrostatic energy stored in each of the two capacitors. So energy at A can be calculated by half of Q square by C. Substituting the values, we have half. Charge on capacitor A is 8 microcoulomb, so 8 square divided by capacitance, that is 2 microfarad. Energy comes out to be 16 microcoulomb. Second, the energy of B is calculated by the same formula, Q square by C, where half charge is 16 microcoulomb square divided by its capacitance, that is 4 microfarad. So answer comes out to be 32 microjoules. This is joules. The third part, that is we have to calculate the heat produced during the charge transfer from one capacitor to another. Now for that we'll use the conservation of the energy, that is, let's say the initial energy of A when it was not connected to any other capacitor, then it was having a charge of 24 into 10 to the power minus 6 coulomb. So I'll use the formula half of Q square by C to calculate the initial energy of capacitor A. That is half of 24 into 10 to the power minus 6 whole square divided by capacitance, that is 2 microfarad, and the answer comes out to be 144 microjoules. Now by the conservation of energy I can write that E initial minus E final will be the heat loss. So E initial, that was 144, minus E final, that was 16 plus 32, that will be equal to heat loss. So heat loss comes out to be 96 microjoules. That is the answer.